Hello, this is Michael from Fab Lab El Paso. Earlier, you were introduced to vacuum forming as a production method for molding and shaping plastics and other composite materials. Today, we will take a little bit closer of a look at a machine in action. You may be familiar with vacuum formed materials from products and packages. Anything that you kind of have like electronics typically have these molded plastic inserts that hold the objects. These were all vacuum formed in industrial facilities. This right here is a desktop version. This is called the Vacuumform, and this was a Kickstarter funded project to bring vacuum forming to the hobbyists. Otherwise, typically you would have large format vacuum form machines that were used in industrial facilities and typically out of the reach for the general populations. But here, this is housed in a mobile cart used in our mobile fab lab. Our mobile fab lab is full of all kinds of different digital fabrication equipment that we are able to take out to schools and have workshops and classes for students in our region. The Vacuumform has a max build area of 10 inches by 13 inches. Right? We typically stock sheets of PETG or HIPS, which stands for high impact polystyrene, but you could also use other types of thermoset materials such as ABS. We typically use PETG or HIPS because they are both great prototyping materials. They require a lower temperature than ABS, and they are generally safe and do not give off harsh off gases. Both materials are FDA compliant and are safe to use in food processing applications, and you could typically find these in single-use and reusable drinking bottles and other food storage containers. PETG is also found across the medical field. Its rigid structure allows it to survive harsh sterilization processes, making it a perfect material to be used in medical implants as well as pharmaceutical and medical device packaging. Now, the vacuum forming process is fairly straightforward, but depending on the items, the machine, and the type of thermal setting sheets that you are using, some trial and error may be required to get good results. Now, the first is that the machine is loaded up with the sheet material. So we have our sheet clamp right here that we will load up. There are locks that hold this in place. It's important that we have a good tight seal because that allows the vacuum to create a good suction. Then, depending on the machine, there's different settings. Typically, we have a heating element up at the top, that's right down here. This vacuum form could go up to 250 degrees Celsius. For this sheet of HIPS that we will be using, we would be going up to 160 degrees Celsius. So we go through and we adjust those settings. There's also settings for specific materials. There's custom settings that adjust the time and when the vacuum kicks on. So this is going to take a while to heat up, and I'm going to move the camera, take a closer look at this, and we'll go on to the next step. Okay, so as our vacuum former is heating up, I am putting on some thermal protection gloves, and I have gone ahead and inserted 2 male molds into the vacuum former bed. We typically use 3D printed PLA or PETG material to make our male molds. This is an example that we use of a Olmec head. After we thermoset the material, we could then use that material to make molds for, like, for example, for like chocolate making, if you're making cement, like flower planters, all kinds of cool things. We typically like to have little giveaways or little make it take it's for the students when we take our mobile lab. So we do like these little 8-bit hearts. After we mold them, we cut them out and then hand them over to the kids. So our vacuum former is almost ready to go. Once the vacuum kicks on, we'll go ahead and lower the tray. Now that all the air has sucked out, go ahead and turn that off, release the pressure, release the clamp, and then we could take out our material. It is warm and it will cool down relatively quickly, but it is cool to the touch as of now. Once our molds are cool, then we would be able to go ahead and pop these out. Right now, as they are warm, they're still kind of tacky, so they're stuck to the material. But once they're cool, it's a simple pop out and you will be good to go. So I'll go ahead and let that cool down for a second and then move on to our next step. Now that our molds are cold, we could go ahead and pop out the blank and set that aside. And the next step would be to trim. Now, typically in industrial facilities, you would have a die cutter that this would get fed to, and it would actually cut it out with a die, right? But here with this hobby and the desktop versions, we typically just use a sharp blade. And here we have our piece. All right, so now that we have trimmed off our thermoformed sheet, we've demolded it, taken it off. Now we'll show you the next step. So what we made here is a laser cut, custom made packaging for this to sit into. And what this package is going to hold is a 3D printed Fab Lab logo. Now this is 3D printed in the SLA style of 3D printing, or as opposed to the molds, we FDM style 3D printed. So we will be covering these two different forms of 3D printing in later episodes. But what we will need to do with this logo is the 3D printing method as SLA typically gets printed with support structures that we would need to remove. So the support removal process is fairly simple and straightforward with a pair of flush cutters. Of course, right here I am using protection. I got my gloves on and I'm using eyeglasses too, because these little pieces tend to fly out. So this is what's called post-processing. What I would do here after removing the support structures, then I would go through and wet sand this with different grits of sandpaper to remove all the different little defects right there. But this is the end result. Now coming up in later lessons, we will show you how to make files to 3D print objects like this, 3D print nail molds, and you already saw the vacuum forming process. Then we will show you how to take design files to laser cutting.